How's it going, everyone? Welcome, Rodrigo Gonzalez here, and today let's going to now explore about what this functional programming is all about, and especially a particular concept that we went over, which is now list operations here. So we also explored about is it transactions and data structures and async and functionality as utility, but this was a topic that we went over to that. We didn't explore, we didn't understand at the end of the day what this mean. And I want to emphasize here with this list operations as a way to understand and describe this in the most effective way possible, right? While also improving my social and my soft skill. And here we are. Here we are. So I'm going to make a quick recap of all of these particular concepts because this is something that is quite important, especially to understand now what the functional programming is, what this particular approach when it comes to write applications in JavaScript following is the functional approach, because JavaScript per se, it is a dynamic language, which is an interpreted language. It doesn't have a compile phase, right? Which means that also this is a general purpose JavaScript language. So if you take a look at JavaScript, right, and say, hey, what is JavaScript, right? So JavaScript, or this ECMAScript, ECMA 262, which is the definition, the technical definition of this, right? It was designed to be a multi-purpose, multi-paradigm programming language, right? So a lot of people say that this is a flaw of object-oriented programming, blah, 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 yada, yada, yada. But the thing here is that this is a multi-paradigm. And so far we have looked at how can we now create application using the object-oriented programming as well as the functional approach, right? There's no good or wrong. Each one of them has their own specific way, and we want to understand what is the problem that functional programming and object-oriented programming aims to solve. And let's going to ask here Claude briefly, okay? A simple question. Since JavaScript is a multi-paradigm programming language, what is the goal of object-oriented programming and functional programming? When it comes to solve problems, what are the use cases because it's not only about the use cases, is that what are the problems, what are the problems each approach wants, what is the problem, singular or in plural? So what is the problem, or what are the problems each approach aims to solve, right? Basically, what is this, right? Exactly. There are two different that tackle different fundamental challenges in software development. each with distinct philosophy about how structure and organize go. So object-oriented programming primarily aims to solve related to co-organization, reusability, and modeling real-world complexity. Right? So you have managing complexity, breaks down complex system into smaller, manageable objects that represent real-world entity or concept, but it all boils down to this divide and conquer. You say this one and this one another. All right. Instead of having one massive program, you have interconnected objects that handle a specific responsibility. So far, so good, because I have something that I have, and this is important to at least recap, especially when it comes to deal with problems here. All right. Problems like some code challenge that I'm gonna see that later, but this is that. The other is the code reusability through inheritance and polymorphism. Object-oriented programming allows you to write code once and reuse in multiple contexts, which is something that, for example, according to that interview, Grady Butch. Okay, that was a very interesting topic. So according to Grady Butch here, right, he brilliantly mentioned about this. The UML is no longer in use, and how software has changed over time. Grady early works in AI, thought on formal methods. What is the other one? An explanation of UML and why it was a mistake to turn into a programming language. But again, in this particular video, he described is what has been the trade-off, and unfortunately the heavy emphasis in inheritance, because that turns out to be not that ideal. So, in other words, trying to make a particularly program or an interface or a set of rules and behaviors to be effective in different contexts can be problematic, right? So, in other words, you got this. So, something that he mentioned, that keep your level of abstraction in one level. A good question would be is that how many levels of abstractions, and by abstractions, or by level of abstraction, first we need to understand that abstractions are responsibility that we want to put, or behavior that we want to put here in another place, that we know that somehow they connect each other. All right, but to make it much more easy to work and maintain, we put them separate, and we define some way to communicate to that. So these particular questions are very important to answer that, to understand that how many level of abstractions do we have. And also I want to ask here about the abstraction to how do you call it? How do you call it? Abstractions by Uncle Bob. Okay. But on Twitter, right? I think he has some rant here. So rant about that. So Uncle Bob. Exactly. Oh my god. Anyway, exactly. And um, um, anyway, oh my god. He's having fun, bro. He's having fun. Multiple. Oh, talk about here. Talk about here. Talk about here. That's a great. Let me actually bookmark this one. Okay. And about performance, and about comments, functional programming. You know, I think this is something that give. Oh my god. uh, all right. Oh my. Oh, Neil. You know, he's having fun. This is also part of the things that you should enjoy, especially if you're going to dedicate to any endeavor. You need to, holy moly, you need to enjoy that. You need to enjoy that part. So, this is about type, but what I want to look and discuss and understand about this is most likely object-oriented programming. That's good. So let's talk about now this two. Let's go to explore about this. OOP, and the other is the functional, right? Functional. No, function. You don't have that function? Come on, man. Can you so function? That's interesting. Okay. And there you got it. Functional programming. Okay. So let me actually take this. Right, let me actually take this because that will be part of this as the resource section, you know. Especially here in the resource. So resource area. Okay. The resource area. Hey, this is rand about functional programming. From Uncle Bob. And the other is rand. Writing about object programming. So object oriented programming. Okay, which is this is functional programming, and this is not OOP. All right. There you go. All right. So let's go to look at this. Okay. About the functional programming. Yes, it's quite long. As you can see, 3 minutes. It is condensed. Let's get into this.
Functional programming. By the way, I like functional programming. I'm a functional programmer. I do a lot of functional programming. But do you know what functional programming is? Functional programming is programming without variables. How can you program without variables, you ask? Well, you don't use the assignment statement. You never change the value of an existing identifier. How can you possibly?
Interesting. Interesting. Again, this is a very different way of solving problems using computers. In other words, instead of actually you reassign something, which is something that we do a lot of the time in operating programming, functions, well, you do not. Functionally pure, of course.
Possibly do that. You initialize variables and then you never change them.
Exactly. So you initialize a variable and you never change that. You perform a computation and then you assign to that a new one, a new one, a new one, a new one.
That's what functional programming is. Once you make that decision to never use a variable, everything else follows. All the recursion, all the first-class functions, all that stuff follows directly from that one decision. It's not a bad decision to make. It's very helpful. It can help you avoid race conditions. You know, if you don't change the state of a variable, you can't have a race condition. Well, that's not exactly true. You can have race conditions. Why can you have race conditions? Because functional programming is Turing complete. You can write any program functionally that you can write non-functionally. And since that's true, I could write, for example, a basic interpreter in a functional language. I could write a C interpreter in a functional language. I could write a Java interpreter in a functional language, and it all can have race conditions. Why can you have race conditions? Because functional programming is Turing complete. You can write any program functionally that you can write non-functionally. And since that's true, I could write, for example, a basic interpreter in a functional language. I could write
a basic interpreter in a functional language.
C interpreter in a functional language. I could write a Java interpreter in a functional language, and in all of those languages, race conditions are possible. So, you can still have race conditions, but they're harder. You have to do special things in order to have race conditions. So in general, functional programming is a very nice way to have pure functions that don't have race conditions, that can't involve themselves in concurrent update issues. It's not perfect, there's always a way to do it, but it does help. Now, if you're doing functional programming, does that mean you're not doing object-oriented programming? Are the two of them absolutely the opposite of each other? No, that's just so stupid. Right? Object-oriented programming is complementary to functional programming. You can have object-oriented functional programs. It's perfectly possible, and in fact, it's desirable. You still do want to isolate your data into chunks that you might call objects, and you still do want to have polymorphic dispatch in order to change your dependencies and manage your dependencies nicely. You still want all of that, even though you're a functional programmer. You still want all of that, right? Does this mean if you're a functional programmer that you can't be a procedural programmer? No, of course you're still a procedural programmer. Programs are procedures.
Exactly. So programs and functions are, so there is a difference here between functions and programming. We all start with that. So a function is something that takes an input and an output and doesn't alter the state of outside of its scope. Unlike a procedure, you can.
A good programmer is a functional object-oriented procedural programmer.
Wait, what?
Programmer is a functional object-oriented. A good programmer is a functional object-oriented procedural programmer.
So he mentioned something that is about the functional programming. And it's important to recap this particular approach because at the end of the day, this is how you can solve the specific problems. Pretty much with now the object-oriented programming, which is something that we're going to take a look at this. All right.
Yesterday, someone asked me to rant about OOP. I told him to be careful what he asked for. Okay, so here goes. An object-oriented program is nothing more and nothing less than a set of collaborating nodes called objects.
As according to him, it's a set of collaborating nodes called objects. So all of these particular nodes, this is also part of the distributed computing systems. Okay, you can think of this, each one of those nodes, if you're dancing, that each individual person. All right.
These objects collaborate by sending messages to each other.
So these nodes or these objects collaborate each other by sending messages.
The sender of a message
does not care.
Neither knows nor cares how the receiver will respond. At the source code level.
And it's interesting because it's quite interesting, the same as when you talk to somebody, all right? You don't care about you don't care about how they receive or responds to that.
Levels, how the receiver will respond.
Exactly. So you don't care about
neither knows nor cares how the receiver will respond.
Exactly. Most of the time you don't care about how the receiver is going to respond. Most of the time we want. When you talk about in person, in people, most of the time we care about what the other responds. But in our case, we doesn't.
At the source code level, an object is described by an entity known as a class.
And at the source level, which is at the structure, is described as a class.
A class can be divided into two parts, the interface and the implementation.
So this source level or this structure can be divided on its implementation, the behavior that it have, as well as the implementation and the interface.
Base and the implementation be divided into two parts.
Or the interface, what it communicates to the other world.
The interface and the implementation. There is a one-to-many relationship between the interface and the implementation.
There is a one-to-many relationship. There's a one-to-many between the interface and the implementation.
Many implementations can share a single interface.
It's like the many way of doing things can have the same interface.
The sender of a message neither knows nor cares which implementation is receiving its messages. Each implementation message can share a single interface. The sender of a message neither knows nor cares which implementation is receiving its messages. From that simple description, all the principles and rules of object-oriented programming and design can be derived. Notice I did not say anything at all about encapsulation or inheritance or polymorphism. Those three things are not definitional. They are language facilities. Certain object-oriented programming languages may use them to allow programmers to implement the model I just described. Notice I also did not say that object models are models of the real world. No, they are models of application behavior. Say that object models are models of the real
object model
world. No, They are models of application behavior. Notice, I did not say that objects were mutable. They are not necessarily mutable. Objects can be immutable, therefore it is entirely possible to create object-oriented functional programs. What is the advantage to programming in an object-oriented style? The advantage is simply in the statement that the sender of a message neither knows nor cares how the receiver will respond, or in other words, they are decoupled.
Okay. So based on and I have to do this kind of silly explorations, all right? Because most of the time we try to put all of these jargons and fancy words to make ourselves much more important and to impress our bosses, yada yada yada. But the reality is very simple, especially with functional programming and object-oriented programming. Okay, so the idea is to have objects or nodes that communicate each other. So the sender of a message nor either cares how the response is going to be how the receiver is going to reply. And at the source level, which is at the structure level, you have now is the implementation and the interface. So the relationship between the interface and the implementations are one's too many. So multiple implementations can have, or one implementations can have multiple one interface can have multiple implementations, which makes them much more easy to play and plug and play, right? Check which implementation actually are more effective, more efficient, you name it. So this things like polymorphism, inheritance, all of that are language facilities, places in our code that allows developers to go into the implementation. So this is from the abstract. Okay, notice that it doesn't mention to model the real world. They just note, as they mention here,
they use them to allow programmers to implement the model I just described. Notice I also did not say that object models are models of the real world. No, they are models of application behavior.
Applications behavior, what this stuff should do. That's what is this objects is all about. What is this should do? What this representation should do? Okay, so we need to put a practice of that to actually try to understand that way much more. So you get it. Oh my God, here we go with the memes, Lord. So, because of that, right? And I prefer to go with human rather than this predictability, reliability, mathematical modeling, real world complexity. Modeling real world complexity and mathematical correctness. Okay. Modeling complex domain relationship, banking system with account, customer and transactions. Build large application that need clear organizational structure. This is when it shines. Creating reusable components with varying behaviors. Working with stateful systems where objects need to maintain and modify their internal state over time. And this is when functional programming excels. Processing and transforming data like filtering, mapping, and reducing collections. Building reliable, bug-free system where predictability is crucial. Creating concurring or parallel programs, and there is a difference between concurrency and parallelism, right? So parallelism are programs that are executed at the same time, whereas concurrency are programs that overlaps at a time. Okay, so I'm running this, and then suddenly something happens. So I need to stop this to go with this another task, and one task it is done, so I can switch back, or I can go to another one task, and so on and so forth. A good example of concurrency is, for example, if you are cooking, let's say you're preparing a salad, you have all of your carrot, onions, you need to hash is the legumes while you are boiling some eggs, and you already put on the oven. So you already put on the oven the steak, and well, now you suddenly receive a call, and it's your mom, and it's telling you that by the weekend they go out to some dancing classes, and she would love to go with her. Right? Good, great. So that's that. What happens there is a concurring events. You know, it's our task that overlaps at a time. So, why this is important, and why do we even care about this? Because understand this OOP and functional programming. So anytime that you need to do some transformations, or when reliability is needed, functional programming is a way to go. So try to do that, right? So for example, doing transactions, performing and transforming data, handling transaction and concurrency, right? However, when it comes to now model is applications behavior, that's when our Unity programming says. So our applications behavior is that, hey, I want this to be done. I want to store this data, I want to read this data, and that kind of stuff. Building large applications that need clear organization and structure. So, because of that, and since now JavaScript, all right? And since now JavaScript is a multi-paradigm language, so depend on the problem that we want to solve, whether it is application behaviors, hey, I want this application, for a good example of this is like, I want this application to have now this, just show me this, or allow users to do this, or to toggle between this and another one, or to toggle between here to show different images or color, you know. So this is a good way of using Unity programming. When it comes to now, when reliability is needed, because I will say that when reliability is needed, then you can use is now functional programming. Okay, so for example, it's like a reliability is to say, hey, I want to now, anytime I toggle this, I want to show that, right? That's a good way of how you can do this. I want to show this in a reliable way, all right, similar to this or this. But anytime you want to model applications behavior, Unity programming is a good candidate for that, because it provides now a particular structure. However, when you want to implement that behavior, all right, functional programming seems to be a good way to proceed. Let me actually, in fact, I see. So for example, if you want to describe the application behavior in an app. For example, the appearance, object-oriented programming is the right candidate. However, if we want to implement the appearance behavior, for example, color, so change dark and light, or toggle, toggle to dark and light theme, so for example, toggle to dark and light themes. Resize images, display different display different layouts. Functional programming is prefer do the deterministic behavior. You identify crucial distinction that many developers overlook. These separations reveal why modern JavaScript applications often use both paradigms strategically rather than using just one. This is the theme manager because you want to describe this application behavior, or this is user stories, okay? You want to describe the application behavior, otherwise it's the user stories. The user stories, hey, I want to now this, so I can define is that the theme manager and the UI components. But when it comes to implement that, model the relationship between components and themes, all right? And you say, hey, I want to toggle that, I want to apply a particular theme, I want to resize the image, I want to set the layout, do that. So you have now the hybrid approach in practice. You say, this application that allow you to now is described as the behaviors of this theme manager and layout manager, where each one of them objects are going to implement that. Encapsulate theme, state, and relationship. Add observer, the component, and this observer.push. Okay. And state updates, FF-ish behavior. We have the functional programming behavior. So, with that, all right, we went over to describe is in the context of functional programming, when you want to have a deterministic behavior by relying on mathematical fundamentals, and you're going to avoid an entire classes of bugs, and at the end of the day, you will need to have at some point a place in your applications that needs to change the state. But anytime that you rely on functional programming or a model, the files, a set of files that rely on functional programming, you know that that will work as long as you follow the functional programming paradigm, you know that that will work as expected. And that's why we talk about function purity, which is a fancy word to say it has several rules that we want to follow in order to get the benefit of the mathematical fundamentals, right? And understand the difference between a procedure and a function, that at the end of the day, with functions are just receiving an input and returning an output, and it doesn't alter the state of the application outside of the function, okay? Whereas with procedure, you can. So to be now a function pure, all right, we describe here about the argument adapters, point free, closures, but we went through, look at the function purity to say, hey, this function that can is modified is the state of the application outside of the function body, as long as that is in an enclosure scope, or as long as that now is in a closed scope. So not only that, that function purity is also something that follow this referential transparency, which is a fancy way to say anytime that I call this function, if I can replace the output in any place of your application, and this is also something that I want to ask to Claude, if I can replace the output of that function, okay, in any place of the application without modifying the state in an unexpected way, that is a referential transparency. Referential transparency, like this. So a function call is pure when you can replace the returning value and not affect any of the rest of the program. This is known as the referential transparency. So the referential transparency, okay? So the referential transparency is referential transparency is a function, a pure function that when it's called, the output, exactly, or the return value, or the output doesn't change the app or the rest of the program in an unexpected way, or doesn't change the rest of the program in an unexpected way, or doesn't affect the output, doesn't affect the rest of the program, right? That's what the referential transparency is. Actually, there is a small mix-up in that definition. Let me clarify what referential transparency is. It's a property where an expression can be replaced with its value without changing the program's behavior. In other words, if you have an expression that evaluates some value, you should be able to substitute that value directly whether the expression appears, and the program will work exactly the same way. But you're describing a function that doesn't affect the rest of the program when it's called is closer to the concept of no side effects or being pure. Okay, so in other words, exactly, your function call is pure when you can replace the return value and not affect the rest of the program. Referential transparency means that it's a function call can be replaced with its returning value without affecting the rest of the program. That makes a lot of sense. Okay, referential transparency, which is a fancy way to say that. It says that, hey, by the time that I call this function and the returning value, if I can get that without affecting the rest of the program and put it in any place, that's now a referential transparency. That's now is a pure function, which means that we get the benefit of the functional programming. And also some more interesting topic that I'm going to describe that later. I'll be right back. I'm going to the bathroom.